Hello, this video explains the solution for the question number 3 in pairs relationship problem set. This question describes about a sample of clay soil, and the measured details are given, and there are two parts in this question that we need to find solution. It is always a good idea to note down what are the known information given in the question, and also what you need to calculate, and also the useful formula. So I have written down the information taken from the question here. So the weight ratio and specific gravity, degree of saturation are the given information, and you need to calculate the water content, bulk density and the dry density. The useful formula that we will need to work out this question will be the ESR equals WGS and dry density rho D equals rho divided by 1 plus water content, GS equals MS divided by VS times rho W. For the part A, to work out the water content, so the definition of water content is mass of water divided by mass of solid. So from the given information we can see that the mass of solid, from the useful formula we can see that this equation we can use to find this answer. So what you need to calculate is the water content, that will be ESR divided by GS. So all the required information is given. So the void ratio is 0.73 times the degree of saturation is 0.92 divided by the given specific gravity 2.71. So the answer will be 0.248 or 24.8%. So that will be the water content of this clay soil sample. The second thing we are going to calculate is the bulk density. The bulk density is defined as the total mass divided by the volume. So the total mass comprises with mass of water plus mass of solid divided by the total volume. Hence, if we can calculate the mass of water and mass of solid in this clay sample, so we should be able to determine the bulk density. To calculate the mass of water or mass of solid, so first thing we are going to do is we are going to assume a unit volume, or capital V equals 1 cubic meter. So the total volume comprises with the volume of voids plus volume of solid. Therefore, our total volume, which we assume as 1, is now equal to volume of voids plus volume of solid. Now since we know the void ratio as 0.73, the definition of void ratio is volume of voids divided by volume of solid, which we know as 0.73. And if you rearrange this equation, you will get your volume of voids as E times Vs. Now you can substitute that one in the previous equation, which will be now 1 equals volume of void, which is EVS plus Vs. So that will give you 1 equals Vs times 1 plus E. From that you can determine the Vs, which is 1 divided by 1 plus E. You can substitute the E value as 0.73, that will be 1.73, so that will give you your Vs as 0.578 cubic meters. Since we know that 1 equals Vv plus Vs, now we can actually calculate the Vv. Your Vv, which is the volume of voids, is 1 minus volume of solid. Therefore, your total void volume will be 1 minus 0.578, which will give you Vs 0.422 cubic meters. So now we know the total volume of voids and total volume of this is volume of voids, total volume of voids and total volume of solid. Now what we need to calculate is the mass of water. So if we can calculate the volume of water, we can easily determine the mass of water. To find the volume of water, the total void volume is 0.422, but we know the degree of saturation. So the degree of saturation is defined as volume of water divided by total void volume. So since we know this degree of saturation value as 0.92, your volume of water will be VW and the total volume of voids is 0.422. So that will give you the volume of water in this soil sample. That will be 0.388 cubic meter. So now we know the volume of water. So from the volume of water, if you want to calculate the mass of water, so we can simply use this relationship, the density of water, which will be mass of water divided by the volume of water. So from this we can get the mass of water as 1000 times, 1000 is the density of water and the volume of water is 0.388, which will be 388 kilograms. And then once we have determined the mass of water, we need to also determine the mass of solid. So the mass of solid, to calculate the mass of solid, we can simply use the relationship of GS. Yeah, from the GS relationship we can calculate the mass of solid. That will be GS times Vs times rho W, density of water. So we know all the values to calculate the MS from this equation. So your MS will be 2.71 times 0.578 times 1000. That will be 1566 kilograms. Now we have determined our mass of water in 1 cubic meter volume of soil, 388 kilograms, and mass of solid as 1566 kilograms in 1 cubic meter volume. So now it's a straightforward calculation for determining the bulk density, which will be mass of water plus mass of solid divided by the total volume, which we assumed as 1 cubic meter. So that will be 388 plus 1566 divided by 1. So that will give you 1954 kilograms per cubic meter. So that will be the bulk density, and similarly we can calculate the dry density. So the dry density is defined as mass of solid divided by the total volume. Mass of solid we have calculated as 1566 divided by 1. That will be 1566 kilograms per cubic meter. So that's all for part A. Part B of the question asks you to calculate the water content if the soil is saturated. If the soil is saturated, first thing you need to know is degree of saturation, SR is equal to 1. And the second thing is total volume of voids is now occupied by the volume of water. So the total volume is occupied by water, therefore the total volume of voids is equal to volume of water. So we first calculated the volume of voids as 0.422 in 1 cubic meter of soil. Therefore the volume of water is now 0.422 cubic meter, which is equal to the total volume of voids that we calculated before in a 1 cubic meter of soil. Now since we know the volume of water when the soil is fully saturated, we can also calculate the mass of water, which will be the density of water times the volume of water. So the density of water is 1000 kilograms per cubic meter times the volume of water we have here is 0.422. That will give you 422 kilograms of water if the soil is fully saturated with water in 1 cubic meter of soil. Now the water content, which is defined as mass of water divided by mass of solid, and mass of water in 1 cubic meter of soil we have already calculated 422, and whether it is saturated or not, the mass of solid is not going to change. Mass of solid means the total mass of soil particles, so that will still stay the same that we calculated before as 1566. Therefore, your water content will be 0.269 or 26.9%.